one. Then also when you come to group 7, since they only lack one electron to be full, they are more reactive than group 6 elements, than even group 6. They are more reactive than group 5, like that. So group 5 are less reactive, group 6 are less reactive, but the most reactive are group 7 elements because they only lack one to be full. Now let's reason it out. If they react by attracting, fluorine has 2 shells, 1, 2. Then let's look at the one of what? Bromine or chlorine. Chlorine is like this. Then there's another electron there. So they have 7 outermost electrons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This is the nucleus. This is the nucleus. So this one reacts by attracting. Okay, by gaining electrons. They attract electrons here. Now, if something is small, the force of attraction holding this electron is so strong, isn't it?
Yes.
Just like group 1 elements. The force of attraction between the nucleus and the last electron is so strong here than in this one, because this one, it is somehow weak. Now, for nanometals, the reactivity changes. Since this is our nucleus and the last electron, since the force of attraction between the two is so strong, so this one has the ability of pulling electrons fast than this one that is big. You get it? Yes?
Yes.
So this one will be less reactive than this one. This one will be more. This one will be less reactive. That is the only way out there. So more reactive of nanometals is group 7, and the more reactive element there is fluorine, followed by chlorine, followed by bromine as we go downwards. So for metals, reactivity increases as we go down the group, because lithium, the electrons are strongly bound, so losing that electrons is hard. Other than this one that are down here, losing them is easy. For nanometals, then the last electron is strongly attached to the nucleus, so pulling electrons become easy for that one. So this one is more reactive. So fluorine becomes a more reactive nanometal, followed by chlorine as we go on. Since group 7 are more reactive than group 6, so they are more reactive. So if a question comes asking, they draw for you a table like this. Then they put here, this is 1, 2, 3, 4, 5, 6, 7, and then 8, like that. Then they start putting here elements. They tell you that elements in this table are not, the symbols may be used are not of the same of the element, but they represent that atom. Now here they put A, they put here B, then they put here C, then here they put X, W, and then Y. Then they will tell you to arrange metals in increasing reactivity. Then arrange nanometals in increasing, these are metals, then nanometals. Which one is going to be your first metal in the series? In the table, using this one we have drawn, which one is going to be a first element you are going to put there? In increasing means we are going to start from the least reactive as we go to the most reactive, isn't it? Yes? Are we there?
Yes.
Good. So if they say arrange metals in increasing reactivity, increasing, we are going to start with the least reactive as we go to the most reactive. So which one is the least reactive among group 1, 2, and 3? Which one is the most reactive? So you start with those ones of group 1. They are more reactive than group 2. Even group 2 are more reactive than group 3. So when you're arranging this, you start the most reactive is A, so you put it aside. Maybe they can put here C. Let's look at another letter like D. The most reactive is going to be D. Then we come to A. Then we come to B, and then C. So the order is going to be like that: C, B, A, D. This one is group 3 are the least reactive elements, followed by group 2. Then the most reactive are between group 1 elements. Now, since there are 2 group 1 elements, reactivity of group of metals increases as you go down the group. So the most reactive is this, followed by this, then we go to this and that. So we start with C, B, A, D. Have you understood? Yes? Have we understood?
Yes.
Bridget,
Yes.
have you understood?
Yes.
Ruthie? Ruth? Ruth, talk. Ruth, talk. At least you are whatever I know is okay. Talk. What happened to Pav? Pav's data is off.
Yes, teacher.
Have you understood how reactivity is?
Yes.
Okay. So somebody tell me reactivity of nonmetals. How do nonmetals, starting with the increasing reactivity, nonmetals? Increasing reactivity, increasing. The least reactive nonmetal is?
Y.
It is?
Y.
Y, followed by?
W.
W. Then lastly?
X.
X. Thank you very much. Now people have understood these things very well. Let me pass through these elements here. We looked at the periodic table. We listed the 20 elements. Now, the elements in the periodic table are classified as metals, metalloids, nonmetals, and then inert, they don't react, noble, or rare gases. Metals, these are on the left of the periodic table, the left, and they are of group 1, 2, and 3. Metals react by loss of electrons, Then semi-metals or metalloids, these are found in the middle of the periodic table in group 4. And the most common metalloid we know is carbon. There is a stage you will reach and carbon will behave as a metal and sometimes as a non-metal. Okay?
Yes.
We shall study that one also when time allows us. So noble, rare, or inert gases, all these mean one thing. Noble, rare, inert gases. Inert means something is not reactive. It doesn't react at all. So they are at the extreme right of the periodic table, group 8. This is where you find them. Then nonmetals are not reactive because they are very stable. In group 8, all the electrons are full, so there is no reason as to why they are reacting. That's why they are getting the names inert elements. So, and then transitional elements, these are found in between group 2 and 3. We looked at them last time. Let me show you that periodic table here. You see all these from this 3B up to 2B. 3B, all these are called transitional elements. They have a certain color. That's why they are called transitional elements. They have a certain color they have, and they are all here. You see copper, you see zinc. These are all of them here. MT, all of them. There are as many as this. Even chromium, manganese, iron, all of them are here in the middle. Whatever metal you have not seen in the first 20 elements, Most of them are here. So that is what we know as them. So this is our modern organized table. Pav is still struggling to join. So that is the organization of that work. Then examples include copper, iron, chromium, cobalt. All of them are found there. They have some color. Transitional elements form colored compounds and they have variable valencies. All of them are there. So trend of reactivity of elements in the periodic table reactivity. Elements in the same group react in the similar way because they have the same number of electrons on the outermost shell. Elements in the same group. That one, somebody talked about it, that their reactivity is the same. So elements in the same group react the same way. Reactivity increases as you go down the group of metals. We have seen that one. Because of increase in atomic size of an atom increases. As the atomic size increases, the outermost electron becomes loosely held because there is no longer strong attraction between the nucleus. Hence, such electrons are easily lost. Because metals can react by loss of electrons, the more easily a metal loses electrons, the more reactive that metal is. Have we got the reason now why metals down the group react faster? Yes?
Yes.
So here they are saying, as you go down the group of nanometals, these are nanometals, reactivity decreases due to increase in atomic size. As atomic size increases, the force of attraction of the nucleus and electrons decreases. Hence, electrons cannot be gained easily. So the more easily a nanometal gains electrons, the more reactive that nanometal is. And that's what causes the reactivity of that nanometals. So we find that the most reactive nanometal is fluorine, followed by chlorine, bromine for group 7. Then group 7 elements are more reactive than group 7, they are more reactive than group 8. For metals, group 1 elements are more reactive because they have only one electron to throw. So their reactivity increases as you go down the group. So the most reactive metal is this one, followed by this, followed by this, followed by this, as we go up. Then group 1 is more reactive than group 2. Group 2 is more reactive than group 3. So you must be able to discover how those things are located. So across the period from left to right, observe this. Reactivity decreases from group 1 to group 4. It decreases from group 1 to group 4. We have seen that one. That metals of group 1 are more reactive than those of group 2, are more reactive than those of group 3, because they have more electrons to throw than those ones in group 1. Then increases up to group 7. So it starts from group 5, 6, 7. So it increases. The most reactive non-metal is in the one in group 7, followed by those ones in group 6, then those ones in group 5, and falls sharply in group 8. Group 8, they don't react anyway because their last electrons are full to the maximum. They need nothing to react. So as you go across the period, the effective force on the nucleus increases, hence the outermost electrons becomes more strongly attracted to the nucleus. So is there any question before we go to any other thing? Yes? Questions.
Teacher, this book,
Mm.
where will you send it?
You want it? I promise to send you this book. I don't know why I always forget. But it's fine. I'm going to look for a solution immediately.
So you put in the study material.
I'm going to drop it there in the study material because it is there under senior 3. But now I have to put it in your class also. So this is what we have there. Then now, finally, when you look at ions, ion is a charged particle formed from an atom or a group of chemically combined atoms by gaining or losing or one or more electrons. Ions are either negatively charged. Negatively charged ions are called, they are called what?
Electrons.
Negatively charged. Negatively charged ions. Negatively charged ions are called anions. Anions. Then positively charged are called cations. Okay?
Yes.
So they are no longer called the electrons and protons because those ones are found on the shell. Now, if an atom is reacting, it has to be charged. So if it is charged, it becomes an ion or a cation. So positively charged elements are metals mostly. Then anions are non-metals. Okay. Now, when you come to positive ions, they are called cations. They are formed when an atom or a group of a chemically combined atoms lose electrons. An example, the first element in group 1 is lithium. So when it becomes an ion, it becomes lithium I plus. That is the ion of lithium because it has only one electron on the outermost shell, isn't it?
Yes.
So it becomes 1 plus. So this is what happens to those elements. Let me get for you this one. So sodium, like now lithium, when it loses the electron, the loss of electron is indicated by the negative sign, isn't it? Loses an electron, it becomes an ion of lithium, which is Li plus. That's what it becomes. All ions of group 1, they remain, they do the same way. So now, since it is hard to write this equation like this, it is always better for you to write lithium. When it is charged, it becomes lithium ion plus the electron lost. This electron is always lost. That's for group 1. They always lose 1 electron. Now, when it comes to group 2, what happens?
They lose 2
electrons. An example is calcium. When it loses electron, it becomes calcium 2 plus and then the 2 electrons. Okay? Then when it comes to aluminium in group 3, it becomes aluminium 3 plus the 3 electrons. Is that clear?
Yes.
So if they ask you to show using maybe electrons, using the electronic structure, you should know how aluminium looks like. Aluminium is 2 to 8 to 3. So it is 2, these are 2 to 8, then 3. 1, 2, 3. When it becomes an ion, it loses the 3 electrons. So these other 2 remain. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So it has lost how many electrons?
3.
3 plus. So that is the ion of aluminium, how it becomes. So this one is for this, then the 3 electrons he has lost are there, and then this is what aluminium means. Okay?
Yes.
Good. So in simple terms, this is what they form there. So if they ask for electronic structure of the iron, it must be less by the valence of that element. So all these are, all of them are like that. Now let's look at formation of negative ions. Negative ions react by gaining. So these are formed when atoms gain electrons. Atoms gain electrons so that they acquire a stable electronic configuration as the noble gas. The negative ions or anions are formed by nonmetals mostly. Examples is a chloride ion, an oxide ion, all of them, that is their nature. So in simple terms, this is what they do. This is what they do here. So if this is chlorine, it loses the electron to become, it gains electron, sorry. It gains electron to become a chloride ion. So this one is the representation of that. Oxide loses 2. So you must show us that it loses the 2 electrons to become this electron. So that is in simple terms. So valency, whatever that one, we have learned how to write an equation. So chemical equations, what? This one, we are done with these elements. So now at this level, you know how a structure of an atom looks like, what it is composed of, and the properties of those atoms, division in the periodic table, how they are. And now I want us to go to the next chapter next time, that is reactions. Actually families, the chemical families. Chemical families. Now, when you come to chemical families, we shall get a family of group 1, a family of group 2. Then we have a family of group 7. Then we have a family of, this is 4. These are the noble gases. Noble gases. So we are how many here? We are 5, isn't it? Yes?
6.
6. 1, 2, 3, 4, 5. You are 5. Okay. I will also join one person. But I want the work many to come from you. So since there are 6 groups, 4 groups, the ones that are normally known, this one is found here. Let me take you through this. When you come here, there's that topic called have you seen these subjects called chemical family? Yes?
Yes.
So the first chemical family is group 1, and group 1 metals are called alkaline metals. The second family is called the alkaline earth metals. So somebody should be writing this. The first one is alkaline metals. This one is alkaline earth metals. Earth metals, group 2. So these are elements of group 2 in the periodic table. They are there. Alkaline metals, elements of group 1. Then from there we jump to so meaning by the end of the day I should have posted this book in that group. Then we have noble gases, group 8, and then we have halogens. So me, I'm going to talk about halogens. That's group 7. I know there's something bitter and hard there. So group 1, 2 people should take over. Group 2, 2 people. And then noble gases, 1 person should talk about noble gases. So those are the 5 people there. Are we making the groups now? Huh? Huh? So when you talk about the group, the chemists will talk about the structure number 1, then the composition, and then the properties of that element. Since we started, when you look at group 1 elements, you must look at their composition. What are they? Look at their structures. And then finally, come to their properties. Okay? How they react with most acids, how they react with most what. So that one, somebody will talk, I will be there to guide. Is it clear?
Yes.
So group 1, who is going to talk about alkaline metals? Eh? Now, Catherine, the microphone is disturbing. How are we going to make sure you participate in this exercise? Huh? Catherine. Okay. Let me choose. Let me choose so that people discuss or you read and then you come on. I don't know what you are going to do, but you must be positioned to tell us. Either one person introduces and stops somewhere, and another person comes and continues. But you must make sure that you read the whole thing, okay? This time I'm going to give you time, you separate what you are going to do. Is that clear? Huh? All people should read like that, and then I give questions, they answer, and then they present that day. Which one is the best? I do it the way I did this one. Just give questions and then people talk. Hmm?
Yes.
Okay. But let me start with putting the book. Otherwise, our time is over. Okay. So let me first put the book as a study material in this class, isn't it?
Yes.
Okay. So then somebody group 1, group 2, I will talk about group 7, that one, but somebody can read, then maybe we'll talk about then noble gases. Those are the 2. Then we conclude this. Equations, please keep writing the equations, those ones in the supplementary paper, and then the rest shall be there. Okay. Thank you for attending. I wish you the best of the weekend and the day. Okay.
Yes. Teaching.
Good.